Hello everyone and welcome to my channel Debunking the Debunkers. In this episode, I talk about a new revolution that is taking place in navigation technology, which will revolutionize the way that our navigation systems will work in the future. So, stay tuned as we dive deeply into this technology. Chapter 1. Global Positioning System (GPS) and its problems. We have used GPS-enabled devices for decades now, thanks to the widespread use of satellites, the rapid development and miniaturization of GPS devices, and advancements in sensor technologies. GPS is not only used in the military, aviation, space, and transportation industries, which it was initially developed for, but also in sports, healthcare, banking, and financial systems, construction, and even individual devices like cell phones, watches, and so on. However, there have been increasing problems with GPS and satellite systems that support this technology, which we will discuss in this video. So, where is the problem? As said, global positioning systems, or GPS, are used by many businesses worldwide across a variety of industries, but they are not without their share of issues. These include, but are not limited to, signal jamming or radio interference caused by obstructions such as tall buildings, mountains, tunnels, or walls, a lack of satellites, GPS drifting, which is the difference between your actual location and the location determined by satellites, subpar or cheap hardware, and weak signals surrounding your device, to name a few. Global Navigation Satellite Systems, GNSS, are also susceptible to interference, disruptions in the atmosphere, hacks, and technological issues. These are eliminated by quantum technology, which also guarantees zero drift, enabling precise vehicle location and navigation in any situation. It may even offer defense against unintentional and malevolent attacks. What is the solution? The promising solution to all the issues with GPS systems is a revolutionary technology called the Quantum Positioning System, QPS. In fact, Dr. Giovannetti of MIT proposed the Quantum Positioning System, QPS, in the journal Nature in 2001. But the idea of QPS didn't pick up until 2018, when the Imperial College of London unveiled a prototype of a quantum compass. Then, in May 2024, BAE, QinetiQ, and Inflection companies successfully demonstrated quantum navigation technology in flight. In June 2023, the Royal Navy also successfully tested a quantum navigation system that can determine a ship's location without GPS. At the same time, the U.S. Air Force has started developing and testing the Quantum Positioning System, QPS, in 2023, according to an article published on August 8, 2023, on the U.S. Air Force Expeditionary Center website by Airman First Class Carl Good. According to this article, the U.S. Air Force is enhancing the GPS system through collaboration with Sandbox AQ, a subsidiary of Alphabet, the parent company of Google. Their mission is to solve some of the world's hardest problems using the combined power of artificial intelligence and quantum science, also known as AQ. You can read the entire article by clicking on the link in the description of this video below. How the Quantum Positioning System, QPS, works. The Quantum Positioning System, QPS, utilizes 4 coordinates, which include 3-dimensional space and time. Specialized equipment, including a corner cube reflector and a highly precise clock, achieves this. Furthermore, the system establishes a 2-way classical communication channel with the reference frame's origin. QPS utilizes the principles of quantum physics and quantum phenomena, such as quantum entanglement and squeezing. These features facilitate the transfer of quantum information, leading to enhanced correlation and higher information density in comparison to classical approaches. As a result, the location accuracy surpasses that of conventional radio-based global positioning systems, GPS, by overcoming restrictions associated with signal bandwidth and power. The QPS's primary objective is to significantly improve placement accuracy and effectiveness. It is specifically engineered to operate in situations where traditional GPS systems may have difficulties, such as underwater, underground, or in the presence of interference. Quantum technologies offer an additional navigation system which is very valuable in defense and critical infrastructure applications. Quantum navigation employs quantum technology to mitigate interference, technical malfunctions, and cyber attacks, thereby enhancing positioning precision. Moreover, it can ensure little deviation, enabling it to detect and maneuver around cars in any circumstance with the utmost accuracy. This could offer a significant advantage over satellite-based systems, which are susceptible to interference or malfunction. Chapter 2. Why are China and Russia upset? Our major adversaries, China and Russia, and to a lesser degree North Korea and Iran, are busy with their space programs to compete with the United States and to test our vulnerabilities. One of the key assets of the United States is the global satellite systems. For decades, the U.S. military satellites have been the superior force in the sky, watching every movement on Earth, including flights of aircraft, sailing of ships, launching of missiles, and all the communications day and night. One of the goals of our adversaries, in case of confrontation and possible war with the United States, is how to disrupt or destroy U.S. assets in space. If a few satellites are out, it will disrupt communications and control, firstly in U.S. command and then on other assets controlled by those satellites. Jamming, spoofing, and destroying GPS satellites. Both China and Russia have been investing in the development of technologies such as anti-satellite missiles, GPS signal jamming, and laser weapons capable of destroying or blinding satellites. Therefore, it has become an imminent threat to the United States' national security. For example, on January 11, 2007, China launched a ballistic missile from the Xichang Space Launch Center with the payload of a kinetic kill vehicle, which successfully hit and destroyed a non-operational Chinese weather satellite at an altitude of 863 kilometers in low Earth orbit. We refer to this as a direct ascent anti-satellite attack, or DAASAT. According to an article published in 2012 by the Secure World Foundation, which you can read through the link in the description, one of the dangers of such attacks is that they create thousands of pieces of space junk, over 3,000 pieces in this case, which will become a threat to all satellites and assets in space. These pieces will not fall and will travel in orbit at different speeds almost forever. You can also find a link to China's anti-satellite test fact sheet in the description below. The largest state-owned news agency in Russia, TASS, reported on September 17 that State Space Corporation Roscosmos plans to install a satellite ground monitoring station in Shanghai this year. According to additional reports, China will establish equivalent stations in Russia. This would be the first time either China or Russia allowed another country to place monitoring stations on its soil. The ground stations are the latest development in China and Russia's deepening space cooperation. Since 2014, the two countries have pursued integration of their satellite systems and collaborated on other projects aimed at countering U.S. influence, including a planned lunar base and missile early warning system. Individually, both countries are developing and testing counterspace weapons capable of imperiling U.S. satellites. North Korea is also engaging in the deliberate disruption of GPS signals in the demilitarized zone along its southern border, causing interference for South Korean aircraft and commercial maritime boats in the region. North Korea has engaged in a sequence of deliberate jamming assaults on South Korean military and civilian objectives in recent years, and it is believed that they have acquired Russian-made technology for this purpose. The risk of GPS jamming, which disrupts the ability of GPS-dependent systems to accurately navigate to their intended destinations, and spoofing, where adversaries mimic GPS signals to deceive the user's receiver and misdirect weapons or platforms, is that it can render military weapons either inoperable or pose a danger to their own personnel and equipment. Those are direct threats against guided weapons, and the United States has to develop new technologies, systems, and architecture, both on the ground and in space, to counter such measures from our adversaries. What is the U.S. solution to counter anti-satellite attempts? Short-term solution. The initial stage of mitigating risks to GPS satellites involves the implementation of an enhanced GPS system. The United States military is currently upgrading its GPS system through the implementation of advanced GPS-3 technology. The initiative, spearheaded by the U.S. Air Force and Lockheed Martin, aims to enhance capabilities by delivering more advanced services for location, navigation, and timing, as well as offering state-of-the-art anti-jamming capabilities. The implementation of this technology will increase GPS-3's security by up to 8-fold, while also improving its accuracy and reliability compared to the current GPS systems. The creation of a novel military signal known as M-code primarily advances anti-jam capabilities and enhances security. The current system uses the same frequencies to communicate M-code, however, two types of antennas broadcast it: a high-gain direction antenna and a wide-angle antenna. This allows for a powerful signal that is resistant to jamming and interference. Specifically designed to operate independently, M-code allows users to determine their location simply by utilizing the M-code signal. There are reports that Europeans are also developing their own solutions to protect their GPS assets in space against spoofing and jamming. While military forces are progressively striving to mitigate any vulnerabilities that may arise from their growing dependence on advanced technological satellite systems, the GPS spoofing and jamming technologies are simpler and have much lower costs to develop and install, and unlike expensive assets in space, they can be installed close to vulnerable targets on the ground, and therefore, they are so appealing to our adversaries. However, by harnessing innovative solutions from the leading industries, we can effectively mitigate and control this threat. Long-term solution. There are two fundamental aspects to the long-term solution to counter threats to military assets in space. The first is to force our adversaries and all parties involved in space programs and weapons development to follow the game rules and respect global protocols. If there are no satellites in space, then there is no life on Earth. Almost every activity on Earth depends on satellites above it. Without the satellites, the financial system, transportation, healthcare, communications, and social relations will become paralyzed and useless, and the world economy will collapse in days. The same applies to nuclear weapons. Therefore, it is necessary to keep communication and diplomatic channels open, have safety protocols in place, and make all the players responsible and respect global laws. Second, our complacency will be the end of our superiority. The moment we think that we are the superpower and no adversary can beat us in any form, that would be the end of the game for the United States. While developing new technologies like the quantum positioning system, QPS, and other quantum-based technologies like quantum computing and artificial superintelligence, ASI, is essential, the United States should consistently employ a combination of rewards and penalties when dealing with its adversaries. Economic treaties and multilateral cooperation in global issues would be the best rewards, while the strongest stick would be continuing advancement through new technologies at a pace that makes it difficult for our enemies to compete, especially given that the volume of capital generated in the United States and our military budget surpasses that of our adversaries combined.